I welcome you for the lecture series in the course Mechanics of Solids. Last class we have seen what is torsion. In this class we will discuss about the two kinds of shafts. One is solid circular shaft, another one is hollow. In this class we will discuss about the solid circular shafts. So solid circular shafts, what is the empathy of this particular study? Let us take a shaft which is hinged at both ends. We call it as journal bearing, right? And we have different kinds of stresses. One is bending stress and shear stress and axial loading. And the picture depicts the section of concentrated stress because there is a stress concentration area over there. This shaft, the diameter of the shaft changes from um, particular size to the higher size, and we have a change in cross section, or the area of cross section changes. So this section of the concentrated stress will have certain stress in this stress concentration area, and there is a bending stress due to load, and this is the point of maximum bending moment. So it may be at the center of the shaft, or it may be nearer to the center of the shaft. So, what is a solid circular shaft? A rotating mechanical component with a circular cross section that transmits power and torque through machines and vehicles. So, the name solid, it means it is filled with material and there is no hollow kind of thing, and subject to complex loading conditions. So torsion from twisting force, bending from external loads, axial compression or tension. These are all the various loading conditions on a particular shaft. So types of stresses: torsional shear stress. We all know it is caused by twisting torque applied to the shaft during power transmission, and bending stress results from bending moment created by the load such as gear, pulleys or belts. So whenever we have let us take an engine example, and it is built with all these gears, pulleys and belts combinedly, and these all these power transmitting elements will supply a stress which makes the shaft to bend. That stress is called bending stress. And axial stress, it is generated by force acting along the shaft's longitudinal axis. It may be either tension or compression. We all know what is tension stress and compressive stress. When there is a pull, we call it as tensile, and when there is a push on the object, we call it as compression. So these stresses frequently act simultaneously, necessitating combined stress analysis for accurate design. So torsional shear stress, we have formula. The fundamental formula is tau equal to T into R divided by J, and polar moment of inertia is nothing but pi d power 4 divided by 32. So coming to the visualization of stress distribution, shear stress is distributed in this way. The center of the shaft shear stress is 0, where there is a point, a hollow point, and the intermediate radius stress increases linearly, and outer surfaces maximum stress occurs. So the maximum stress occurs at the outer surfaces. This clearly shows how the shear stress is being distributed. And we have bending stress in solid shafts. We have formula for bending stress is m into r by I. We call it as I as moment of inertia and r as distance from the neutral axis, and m is the bending moment. For circular cross section, we have I equal to pi d power 4 by 64. Critical location: maximum bending stress occurs at the outer fiber farthest from the neutral axis. So axial stress and combined loading, we axial stress generated by longitudinal force, that is F by A, and F is the axial force. So angle of twist and shaft deflection, so alpha is equal to T into L divided by J into G. So this is the formula for angular deformation. Design significance essential for assessing shaft deformation under operational torque loads. Failure prevention, exist twist causes misalignment, premature wear, and mechanical failure. So this is a small mind map of all the things we have seen in this stresses in the circular shaft. I hope you all able to get it. And we have a quiz here in which the solid circular shaft subjected to pure torsion, the maximum shear stress occurs at the outer surface of the shaft that we have seen in the diagram. The shear stress distribution across the radius of the circular shaft under torsion is linear at zero and maximum at the surface. These both answers will tell you how we have understood the topic. And these are all the references. So thank you all for your patience listening. Let us all meet in the next lecture series. Thank you.